Alright guys, shh. A man can swim at 3 meters per second in still water. He swims across a river with 60. The river flows with constant speed of 5 meters parallel to the straight banks. This is very kind of them. He swims at an angle of alpha upstream. They don't have to give you that. They don't actually have to give you that diagram at all. Really, they can just ask you, if they were being meaner, they wouldn't give you any of this, right? And you know what they'd say? Find the time taken to go for the shortest path. They wouldn't give you any of the scaffolding to guide you through the question. They just go straight there to there. They're allowed to do that, by the way. You're not guaranteed any of that information in A part 1 or in the description of the question. Everybody cool with that? So there is 2 methods for doing this. We'll go through both of them today. So usually what we've been doing in the book is we do usually aim upstream, don't we? Angle alpha. And then, so first thing you have to decide on is what formula are you using? Are you going to use man in the river or the river in the man? Yeah, only one that makes sense, doesn't it? So it's velocity of the man in the river equals the velocity of the man minus the velocity of the river. The actual velocity of the man is the velocity of the man in the river, the velocity of the man in still water plus the velocity of the river. If you get a bit confused on the day, picture somebody swimming straight across at speed, 3. Picture the river going across at 5. What would his actual speed be? 8. You add them together. Man can swim 3 meters per second in still water. The river's going 5. To an observer on the bank that's not moving, he's going 8. That's how you check your formula on the day. It's a good common mechanism for in a test that you're verifying your formula with a really simple example, and you know you're right. Okay? You don't just think it, you know you're right. Okay? Now, let's continue with this. Alright? So, the first thing we're going to do is we're going to break up the velocity of the man in the river because he's attempting to go a 3 to the left. Now, unfortunately, a few of you has actually put 3 to the right, so I had to take off some marks for that. Alright? So you're going 3 to the left, and that does make a difference. I think there was one person who mixed up sine and cos here, but somehow it auto-corrected in the next line. It was interesting. So 3 cos alpha, yeah? And then 3 sin alpha. Somebody had that mixed around, and then it fixed itself on the next line, so just be wary of that. Okay? And it's minus 3 cos alpha. Why? Because you're going to the left. And then it's plus 3, I. And then it's plus 3 sine alpha j. Okay. Next thing we're going to do is the velocity. Now, the actual, we're going to do the velocity of the man. And the velocity of the man is the velocity of the man in still water plus the velocity of the river. Okay, let's add these together. So what we're going to get is, so velocity of the river, right? Velocity of the river is 5I. Happy days. So we're going to add the 2 of these together. And what we're going to end up with is 5 minus 3 cos alpha, I, and then plus 3 sine alpha j. We all good with that? Now, we're asked to find what tan theta is, and what we know about tan theta is how you got brought up upstream. Okay? So you got swept upstream by tan theta. So, what we're going to do here is that's 5 minus 3 cos alpha, and that's 3 sine alpha. Therefore, tan theta equals 3 sine alpha 5 minus 3 cos alpha. Alright. What do you want to happen? For this to be the shortest distance possible, what would you like theta to be? In an ideal world, what would theta be? The value of theta? It'd be 90 degrees. You can only do 90 degrees when you can swim faster than the current itself. Alright? Failing that, you want theta to be, what's the word I'm looking for? You want theta to be a maximum. And what does maximum usually mean? Differentiation, put it to 0, find the value that will cause theta to be a maximum. Now, the other thing I think some of you are missing is that tan theta, it gets bigger according to the angle, okay? So if you go to your, if you enter tan theta into a calculator as a function, you're trying to figure out what makes it bigger, okay? So, what happens here is, you go tan x, make sure it's in degrees for once. Right, and you're sort of trying to explain to yourself what's going on in the exam. And you go, no bother, I'm going to go from 0 up to 90. I don't know, steps of 5. Why not? What's happening to tan theta as the angle gets bigger? What's happening to it? It's also getting bigger. So the bigger the value is for tan theta, the bigger your angle. So you're looking for if tan theta is maximized, then your angle is maximized. So essentially just put tan theta equal to y and differentiate as normal. U and v. Okay, u is 3 sine alpha. What's the u dx, or sorry, the u d alpha in this case? Should probably look at my solutions. 3 cos alpha. And then v is 5 minus 3 cos alpha, and then dv d alpha will be, what's it, cos changes into minus sine, so minus 3 minus sine alpha is plus 3 sine alpha. Now you're going to do the first derivative, okay? So in a way it's almost like dy d alpha. And what you're going to say is phi times, so 5 minus 3 cos alpha minus 3 sine alpha and all on the bottom is 5 minus 3 cos alpha. You want it to be equal to 0, don't you? Why do you want it to be equal to 0? It's a turning point, isn't it? And at turning points, the first derivative equals 0. Because it's a max, the first derivative equals 0. Okay? Also, and the minimum's quite obvious. You just don't attempt to go across the river. Right? That's the minimum when you think about it. Now, that's squared. Cross multiply up doesn't exist. So you're going to get what's that, 3 cos alpha, or is it 3 sine alpha times another 3 sine alpha, sorry I dropped the 3 sine alphas there, so it's going to be 15 cos alpha minus 9 cos squared alpha minus 9 sine squared alpha equals to 0. What do we know about this part here? Cos squared alpha plus sine squared alpha equals 1. So now it's 15 cos alpha minus 9 equals 0. Then after that, cos alpha equals 9 over 15, which is 3 over 5. And this means, alright, so you're here. What's the goal of the question? The goal of the question is the time taken to get across. Now I'm going to go very direct on this. What's the only part of the question? What's the only velocity going straight up? What component is going straight across? Straight up. Anybody? The 3 sine alpha. So would you all agree it's 60 divided by 3 sine alpha to get your time taken to cross the river? Because it's the only part going directly upwards. So I'm going to say, oh dear, I'm going to say 60 divided by 3 sine alpha. Now, if cos alpha is 3 over 5, I can guarantee you sine alpha is 4 over 5. Why? 3, 5, Pythagoras theorem to get the 4, and then alpha will equal 4 over 5. 60 divided by 3 times 4 over 5, and what do we get there? Anybody? 25 seconds. Okay. Who used the differential method? Okay. So I'm going to go back up to the top. Some of you attempted it. So it was a good effort, right? So here's what you did. You kept this part here. This is just for part 2, not for part 1. Okay, so you kept this information here. Okay, and here's what you did instead. You did it by trigonometry and not by vectors. So, come on, there's your river. Okay, and what you did was you just completed the triangle. When you attempt to go to the left, which one of them is it? It's VMR. Okay, where do you actually end up going? Downstream, what angle? Theta, yeah? So that's Vm. Vm equals VMR plus VR. So if you attach VR to VMR like that, you've successfully completed a vector triangle. Okay, and that's VR. So if you imagine your start is here and your finish is here, you can either take Vm as a direct route, or you can travel VMR followed by VR. The bottom line is you end up at the same place. Okay? Next thing you do is you throw in some angles. We know this is angle alpha, don't we? So what does that mean about the triangle itself? What two angles do I already know? Huh? Yeah, I know that this is angle alpha. I know this is angle theta. Okay? What angle? Pick another letter. Any letter? Beta. Yeah. Alright, good man. Somebody's been studying the solutions because they always use beta. They don't use any other letters really. Now, next thing. Velocity of the river is what, guys? 5. Velocity of the other one? 3. Now, this is such a cheap method, and I'll explain why. Oh, sorry, 5 and 3. Ready for this? 5 over sine B and 3 over sine theta. Only one of them makes sense. You're always going to set one of them to 90 degrees. Okay? Can theta be 90 degrees? No. So you know it's not that one. Also, the maths won't make sense. What happens if I set theta to 90 degrees? What will actually happen then? I'll get sine B is 5 over 3. But sine can only have a maximum value of 1. Means you're going nowhere. There is only one choice. And it's a really obvious choice. Beta has to be 90. The smaller beta is the biggest angle in that triangle, no doubt. And the smaller beta is, the bigger theta will be. It makes sense from 3 different fronts. Alright? So now what we say is it's going to be 5 over sine 90 equals 3 over sine theta. And then you're just going to get sine theta is 3 over 5. Direct route to the answer, yes?
I don't understand why it has to be 90.
So, I'll pause this for a sec. So, imagine that we didn't set sine beta to 90, okay? And we isolate sine theta on its own. So we're going to isolate sine theta on its own. And here's, usually it's a learn off. You know that one of them has to be 90 when you only have 3 pieces of information. The other way of thinking of it is like this. If you can't remember it on the day, 3 sine beta. You want theta on its own and you want to maximize theta, correct? Alright? So 3 sine beta over 5. Now, if you go to your table function on your calculator, and instead of writing tan theta, you do sine theta instead. What you realise is that sine theta has its largest angles the bigger the angle is. Does that make sense? The closer you are to 90, the bigger the value of sine theta. Alright? And you notice that sine has a maximum value at 90. And anything above 90, it actually gets smaller again. So, for argument's sake, if I go 110, if I go all the way back down again, you'll see that sine becomes negative. It starts to lower then. It gets lower again. So it reaches its peak at 1 and lowers it down. So the value for beta to make this as large as possible is actually beta equals 90. That gives you the largest value of sine to inverse, and hence the largest angle. Okay? So therefore, we all know that sine theta equals 3 over 5. Advantages: it's much quicker. Disadvantages: some people find it hard to remember that and find it hard to visualize. The differentiation method might be easier to do, especially if the question is laid out like the one we just did. Okay? So there's advantages and disadvantages to both. It's definitely quicker. And then we just do 60 divided by 3 sine alpha, which is... Now, here's the interesting thing. See the way I had sine alpha, but this time I actually have sine theta, don't I? So things are different this time, alright? So I will actually have to come back here and finish off the question slightly differently. Right, so here's how we're going to finish off the question. So, just in the other methods, we found out what cos alpha and sine alpha was. In this method, we actually found out what theta was directly. So the two methods do differ in that regard. So here's what we're going to do instead. Alright, so we know that you go 60 across the stream, don't you? Everybody cool with that? Alright. Now, I could do with finding out what Vm is, couldn't I? Velocity of the man. So if I know this is 90 degrees, what type of triangle is that? So what does that make Vm? It makes it 4. How do I know it's 4? Pythagoras. It's a 3, 4, 5 triangle. So for those of you that are probably struggling to see that under all the writing, we've all agreed that this is a right angle triangle because we set beta to 90, and therefore it's the hypotenuse is 5, and means Vm is actually 4. Is that alright? Now we know this is 60, and we know that this is theta. How do I find out the diagonal? What can I say about the diagonal? Sine theta is 60 over d. d equals 60 divided by sine theta. And what is sine theta? So 60 divided by 3 over 5. Is 100. Is everybody happy with that? So you cover 100 meters on the diagonal, but you cover that at 4 meters per second. So what would that mean? 100 divided by 4? 25 seconds. Exactly the same answer we got last time. Alright? Okay, let's move on. Now, this part was killer, and the marking scheme was ludicrous. They gave 20 out of 25. The easiest 20 I've ever seen in my life. Alright? So, for those of you that watch rugby, alright, and you've heard of the term running a line, haven't you? Okay? So, if there's a winger, and Mr. Kenny is playing Division 11 rugby, alright, and this skinny dude is a lot faster than me, we're assuming he isn't going to change direction. Is that okay? So it's a one-on-one in open space. And what he goes is, look at this dude, he's not fast, I'm going to go this way. Is that alright? And he decides that whatever angle, he has a higher top speed than I have. Okay? So for argument's sake, I'm going to say he has 10 meters per second. Right? And then So he travels 8 across and 6 up. We're currently level. What's the only thing I need to do to stay in front of him? I just have to go 6 up. So even if my maximum speed is 6, I can still get in his way for a tackle. Because every single second he's going 8 across, 6 up. Wait. 8 across, 6 up, and I'm just going, fair enough, 6 up. He goes 8 across, 6 up, and I go, no bother, 6 up, tackle, and we're done. That's how easy those first 20 marks were. Alright? So, if we eliminate this to ship A and ship B. Right? Ship A, constant speed of 10, direction 30 degrees north of east. No bother. 30 degrees north of east. I know, I'd be kicking myself as well. 10, right? 10 cos theta and 10 sin theta. Is that okay? So, sorry, 10 sin 30 and 10 cos 30. And that is 5 root 3 and 5. So, speed of A is 5 root 3 I and, what's the other one? 5j. And you can just write a little note. Since they're level to begin with, aren't they? What does it say? Ship B is all the way over here. That's ship A. You're ship B. You're already level, aren't you? So what's the only thing ship B needs to do to match its speed? Just go 5 up. Velocity of B is 5j. And what does this ensure? If you really want to get technical about it, you don't actually. You can say that velocity of A relative to B is going to be VA minus VB, and then you say it's 5 root 3 I plus 0j. Why is it 0j? 5j, take away 5j, and then you say collision will. If you really want to spell it out. So the V minimum is 5. That went for 20. It shouldn't have went for 20, but it went for 20. Okay. Now let's drive on next. Okay. We're going to go for if V actually equals 6. So the fact that V equals 6 means you actually have you actually have a bit of a, what's that word? You can afford to run with 2 different things, alright? So once again, you guys are into your rugby, right? 2 ways of doing this, okay? Once again, Mr. Kenny trying to defend the 13 channel for some reason. I have 2 options. I can match in this case his I component, and I can go for a direct collision like that. All I have to do is match his I component. Do you get what I'm saying? If he goes 3 across, 4 down, no matter what speed I'm going upwards, I just have to make sure I go 3 across. What's the other method? It's like what the 13s sometimes do. I can always run backwards, can't I? So I can always run backwards like this, but what's the deal? I just have to make sure that my downward components, see the way he's going 4 meters per second down every time. If I'm anything smaller than 4, he's going to catch me up and bump into me, isn't he? So if I went 3 across 2 down, every second he's gaining 2 meters on me directly down, and the collision will occur. So essentially that's what you're doing. It's like a soft defense versus a hard tackle. It's the same deal. Alright? Now, that's why you hear the term, they have position on them. It means the position is king. You don't have to be as fast once you have the position on them. Okay? So, the J components have to be the same. So what does that mean? 5. And that's 6, isn't it? We already have the angle, don't we? So what angle is this? What's a sine theta is? 5 over 6. And what's sine inverse 5 over 6? 56 degrees and 56.4 degrees, okay? Now, What direction am I actually going in there? West 50, sorry, that's a percent. West 56.4 degrees. North, is that okay? Now, what's the other answer? What happens if I went this way? And I decided to match it with 5 and 6 again. So what's the angle this time? East 56.4 degrees. North. How many of you put down both angles? Okay, now this is where things get troublesome for you, alright? Because some of you wrote down the answer wrong. So, some of you did 180 minus 56.4, didn't you? Alright? So, and what was the number for that then? 123.56. And you decided to write west 123.56 degrees north. And I'm going to explain why that makes no sense. Alright? You're going west. You go 90 degrees north. Where's the other 33 degrees going to go? I'm already as north as I can go. I know you meant west 123 degrees clockwise, but you got to adjust it that now you're going east, or you have to say it's north 33.56 degrees east is the other answer, okay? So that's where you sort of mucked up there.